Hello and welcome. Let's talk about some literature searching techniques and methods. Oops. Okay, so data searching, there's a few different ways and reasons why you may be looking for data or different types of articles. The three scenarios I tend to think of are you're looking for specific data. So you might be looking in the NIST chemistry webbook, CRC, other handbooks, maybe the Merck Index. Maybe you're using Google or Wikipedia to try to find physical data, maybe physical constants. You can look those up usually on Wikipedia. Wikipedia these days does a lot of cross-referencing to journals. You can also usually see where it's getting its data from, so you can cross-reference and double check as needed. Now, a lot of times, let's say you go to NIST, maybe we'll show an example of this. You'll see an article that you're interested in. You see that, not so much an article, maybe you see a piece of data you're interested in. Maybe you're looking up an enthalpy of combustion. And then you can actually see what journal that data came from, and you can go back and cross-reference if needed. One of the things I recommend is whenever you're giving a citation in your art, anything in your work, give a citation to where you actually get the number from. Some folks may say, some instructors may say that you should cross-reference to the original literature. Well, my 2 cents is you should only cross-reference to the original literature if you did the work to look the original literature up and verify that the data was correct. So if you cross-reference, that might mean that you're looking up some, you need to look up journal abbreviations. So if you see a journal abbreviation you don't know, you can use this link here. Or you can use Google journal abbreviation for chemistry or engineering-based journals and use something like this link here. I'll show you an example. So if you're looking for, say, the J Chem Phys and you're not sure, oh, we got to put the periods in. So in this search here, we need to put J Chem Phys, that would be the Journal of Chemical Physics. If you have, this journal would be the Chinese Journal of Chemical Physics. Let's do one more. One of my favorite sort of non-main, like an interesting physical chemistry journal that has some fun articles in it sometimes. And I like the name of it is Phys Chem Phys. So that's Physical Chemistry, Chemical Physics. Okay, so you can look those up if you need to. Back to the presentation. Okay, so you can also go to osu.library.edu and search the online journal list. So let's do one of these searches here. It's library.osu.edu. I will fix that. Okay, so if we go to the proper library website, we can go to the online journals list. Maybe we're looking up a journal. Maybe we found a citation for something in that physical chemistry, chemical physics. And so there we go. The reason why you might want to, well, that's an article lookup feature if you use that particular tool there. If you want to look up an actual article, if you just want to browse, maybe we just go directly to the current listed publisher website that we could go through and look up some different articles. Now, the reason why you go through the library site is most journals, you're going to need to have some kind of subscription to be able to look at the content if you actually want to look at an article. So if you want to be able to actually download a PDF, open it and read it, go through the library site and find your articles accordingly. If you're on campus, you may not need to do this if you're logged into an OSU computer that's on the network. You can probably just go directly to and maybe do a web search for the journal name. If you went to Google and tried to Google from home, Phys Chem Phys or Physical Chemistry, Chemical Physics, what you're going to do is you're going to see the journal articles, you're going to see the listings, but you're just not going to be able to look at any of the articles. Okay, so then the last thing you may want to do is do some more general searching. Of course, you could try Google. I don't usually recommend Google for general topic searches. Maybe if you're like just trying to scratch the surface of something you're interested in, that works. But if you're looking for actual scientific articles, use something like SciFinder, Web of Science, Scopus, and I'll show you how to get to, there's a few ways you can get the Web of Science and Scopus. You can go through the library site, and I'll show you a way to get into those through our library link in our Carmen page. Okay, so let's show NIST real quick. I just want to go through NIST and show you what that looks like. So if we go to, and just Google NIST webbook, you can go NIST chemistry webbook too. I don't think there's a webbook for other topics. But so here, maybe you're looking up the enthalpy of combustion of naphthalene. So naphthalene C10, or what is it, C10H 8. Excuse me, sorry. So if we're looking up an enthalpy of combustion of naphthalene, maybe we're going to condensed phase. Now, condensed phase is whatever the phase of the substance is at room temperature. So if it's a solid, it would be the solid phase thermochemistry data. The gas phase thermochemistry data would be the gaseous compound combusting. So when we do our experiment, when you do experiment 3, you're gonna be combusting the condensed form of naphthalene, which is a solid. So here's a delta HF of the solid, 77 plus or minus 10. So you see there's actually a fair bit of variability in the enthalpy. That's the enthalpy of formation. If we're looking for the enthalpy of combustion, 5160 plus or minus 20. And what these are doing is you can look at the individual data points. It's averaging several different published values. Now you can see some different published values have much more neatly tabulated values, but then they average these out, kind of doing an average of all of those data that are published. So, and this is interesting too, because when you go into the lab, it's like you should probably expect to see a fair bit of variability based on what the published values vary for that particular value. You can see the same thing for the enthalpy of formation of the solid. There's some variability as well. So that's NIST. Let me show you one other feature of NIST. That is, if you're searching for a different type of molecule, like a diatomic molecule in experiment 4, you might be looking up and using what's called the constants of diatomic molecules section. So that's at the very bottom here. I like the formula search, the easiest way for me to search. Name search usually doesn't work so good. In the constants of diatomic molecules, what you're going to get is information about, maybe you know what these constants mean, but this would be the harmonic vibrational frequency, an anharmonic correction, a rotational constant, something called a distortion constant, equilibrium bond length. But what these are for a variety of different electronic states of HCl. So you can imagine having the ground state, which is a singlet, kind of where the electrons are most stably. You can then have the electrons at higher energy orbitals, and then those would correspond to different degrees of excited states of different varying energy and varying properties. But we're working with the ground state, which is at the very bottom of the table, signified by the X state. So any compound you're looking up, like CO, HF, HBr, always look for the X state at the very bottom of the chart. If you were to take maybe like a spectroscopy class, you might get to learn what the sigma and the plus sign means, but we're not going to go through any of the term symbols here. But maybe an inorganic, they hit on some of those details, though. I'm not sure if they do or don't. But so anyways, you get your harmonic frequency, your anharmonic frequency, the second anharmonic frequency, the rotational constant, a correction factor, alpha, distortion constant, and your bond length. Okay, so that's basically how you would use NIST and look up some data for that experiment. There is a computational database that has some experimental data in it too. So there's like a NIST computational data bank. So you Google like NIST computational chemistry. I don't know if we really ever come into here at all, but there is some experimental data that you could look up here. And this is posted so you could do maybe test calculations on some different types of compounds. Last thing I want to do is show that library link. So over in Carmen for our page. Better authenticate. All right, so into Carmen, just go into one of our pages. You should be able to find a library link. I'm not in student view. I think it's pretty easy to find though. You can find direct links to some things like CNE News, Science, Nature. So like if you're looking for a top, like a good article on your topic, maybe you just go directly to Science and then just do a literature search here under some sort of topic. And so the way you might do that here is to use like your search bar over here and do like a keyword search. So like maybe you're talking about the rotation of ethane, and I just wanted to show, okay, I don't want to do an advanced search here, but you can do like a topic search, and at least you're gonna be limited to, if you're on a top journal, obviously articles that are in high, in that high tier journal. Now, another technique that you might use is using one of those Web of Science or Scopus searches. And so if we go back, what you might instead do, instead of saying, well, instead of going through every specific journal that you might be interested in looking up articles in, why don't we just do a search with something like Scopus or Web of Science? Somewhere on here, they should be linked. So over here, so some popular databases, Web of Science and Scopus both work pretty similarly. I'll show you Scopus. And so this takes us to the library. You can go to library.osu.edu and get to this as well. Then we connect to the resource. And we can do our keyword search. And then one of the things that you can do is sort by, instead of the newest is the default, we can sort by relevance. So then what you end up getting are, if you're looking up and you're aware of some of the journal articles in this title, Angewandte Chemie, German journal, that's like their German high-ranked chemistry. Journal cited 100 times. You get to see how many times the journal article has been cited. So the magnitude of hyperconjugation in ethane, that's a pretty big journal. You can see, there's Journal of Physical Chemistry A, there's journals that are in JACS. You can also publication count and look at the titles, obviously, and get a sense of finding some high-ranked and high-tier journal articles in the topic, because it's just using an algorithm of how high-ranked the journal is and then how many times the paper has been cited. So you can sort through your topic and find some high-ranked journals using something like Scopus or Web of Science. Okay, so I think that's all I had to share for today. Thanks for the attention.